Prokaryotic DNA is circular, and during this process it will form only one replication bubble. As seen in the drawing, the top of the bubble is the origin of replication. Within this, there are two replication forks, one on each end of the bubble. This is what a replication fork looks like up close. This DNA runs anti-parallel, which you can see on the drawing with how the 3' and 5' ends are on opposite sections of the replication fork. The top strand is the leading strand because it will continuously synthesize in the 5 to 3 direction towards the fork. The bottom strand is the lagging strand because it will discontinuously synthesize in the 5-3 direction away from the replication fork. The first two enzymes I will talk about is the DNA helicase and the gyrase. The gyrase functions in front of the helicase and is a form of a topoisomer. The job of the gyrase is to remove the supercoiling caused by the helicase, which in turn relieves some torsional stress. This stress occurs because the helicase is separating the two strands of DNA, which allows replication to begin. Next we have the single-stranded binding proteins. These are very important in replication as they keep the two single strands separated and prevent them from coming back together. After that, you see the RNA primer, also known as primase. These are very important enzymes because they allow the DNA to connect to the current strands. It is able to do this because it builds a primer on the DNA strand by adding RNA nucleotides to the strand. This addition is decided by the template strand sequence. The enzyme DNA polymerase III is the primary enzyme involved in DNA replication. It moves in the 5-3 function, which means it adds nucleotides to the 3' end, forming a new DNA strand for the leading and lagging strands. As mentioned earlier in the video, the lagging strand is made of multiple segments. This happens because replication is in the opposite direction as the fork. These segments are called Okazawa fragments, and they are made of multiple RNA primers and DNA polymerase III. Next, DNA polymerase I replaces the primer and proofreads the new DNA strands. It makes sure the appropriate nucleotides were added and fixes any mistakes. The final enzyme of DNA replication is helicase. It comes onto the lagging strand and glues together the Okazaki fragments.